as the loop is rotating inside a magnetic field, because attached to a battery, magnetic flux through the loop changes, huh? Magnetic flux right now, zero, parallel. But now, so is there a change in magnetic flux through the loop? Now question, if there is a change in magnetic flux through a loop, this loop inducing EMF? Yes. Yani as a motor is rotating, there will be two EMF. One EMF belongs to the battery, second EMF belongs to the loop. There will be two EMF. Now we will talk about this. So as loop is rotating, as loop of the motors rotates in the fixed magnetic field of the permanent magnet, magnetic flux through the loop changes. This change in magnetic flux through the loop induces an EMF. Yani an EMF is induced in the loop. In this case, there will be two EMFs. One EMF is the EMF of the battery. One end of the battery is positive, other end of the battery is negative. This EMF is named as in your book, applied potential difference of the battery. In fact, applied EMF is much better, but sometimes your book is using what word? We are using that word, okay? Applied potential difference. EMF and potential difference are similar things, remember? So, this is E is representing applied potential difference of battery. But, because the loop is rotating inside a magnetic field, loop, yani motor also has an EMF. This EMF, yani motor's EMF, has a polarization as well, with positive and negative end. Yani one end of the motor will be positive, other end of the motor will be negative. But when I check the polarization, I see that positive end of the battery corresponds to positive end of the motor. Negative end of the battery corresponds to negative end of the motor. What does it mean? Now let's follow the electric current direction of these two EMFs. Okay, so first I will represent the battery's EMF by red. Electric current of this EMF, electric current starts from positive. Let's follow it, okay? It goes this direction, huh? Follow, it goes through the wire, then passes through the motor, and comes to negative terminal. This is the direction of the electric current by the battery, by the EMF of the battery. But motor also has an EMF. Yes, motor will also provide an electric current, but motor's electric current will be in the opposite direction because its polarization is different. Now let's follow. Electric current I will represent it by blue current. It starts from positive, huh? Goes through the wire. As you see, their directions are opposite. So if two currents are opposite, to get the net current, what should we do? We have to subtract them. Yani, this motor's EMF, motor circulates a current in the opposite direction of the battery. That's why this EMF sometimes called, not sometimes, in your book, in this title called back EMF. It's called back EMF. If it's normal induced EMF, no different than induced EMF we studied. Remember the equation induced EMF, Bano, maximum induced EMF? Bano equation? Yes, by this equation we calculate. It's no different than induced EMF because we are rotating a loop inside a magnetic field, just like generator. Equation is same. However, electric current of this EMF is in the opposite direction of electric current of the battery. That's why it's called back EMF. It is called back EMF because it acts. EMF acts to reduce. What does reduce mean? Decrease. It acts to reduce electric current in the loop. Yani, say that this electric current provided by the battery is 10 ampere. 10 ampere. Motor's back EMF provides a current, say that 5 ampere. What is net current? 10 plus 5. It becomes 5. As you see, it decreased, huh? Yeah, reduced. That's why it's called back EMF. Don't forget, it's just usual EMF, what we know. Only because its current direction is opposite of direction of the current of the battery, it's named as back EMF. We are going to subtract the EMFs. Why? Because their current directions are opposite. Then, potential difference supplied to the motor, V, is equal to the difference. What does difference mean? Subtraction. Difference between which two? Between the applied EMF of the applied potential difference of the battery and back EMF. E minus, E back. This statement is ministry exam question. This statement is ministry exam. Yani applied potential difference to the motor is equal to A, only back EMF. B, only applied potential difference. C, addition of applied potential difference and back EMF. D, difference between the applied potential difference and back EMF. So difference between applied potential difference and back EMF, and we represent it by E minus, E back. Yeah, and this statement is explained by this equation. V is equal to E minus, E back. As I said, this back EMF, in fact, usual induced EMF. What is usual induced EMF maximum value equation? Banu. Banu is available for back EMF as well. Back EMF Banu. Okay? Then, according to this equation, as motor's coil rotates faster, what does it mean? Rotates faster. Omega increases. If omega increases, tell me, how does back EMF change? Increases as well. Yes. If omega increases, back EMF increases. There are 3 ministry exam questions about this. Yani as omega increases, back EMF increases. They're directly proportional. Now I will make a table. In this table, there will be 4 quantities. One of them is omega. The other one is E back. Yes, as omega increases, E back also exactly. What if it decreases? Yes, if it decreases, E back will decrease. Yeah, if I will write it later. What about potential difference supplied to the motor, V? Battery's EMF constant. Every battery is a fixed EMF. For example, battery inside, these batteries are 1.5 volt. They don't change. These are fixed. If this is fixed, but E back is increasing, what do you expect omega V to be? It decreases. If this increases, that subtraction. You subtract it. If this is greater, this gets greater, this gets smaller. So then let's put it here as V, potential difference applied to motor. It decreases. If V decreases according to Ohm's law, decreasing V, what about I? Decreases, directly proportional they are. What if omega decreases? If omega decreases, back EMF decreases. If back EMF decreases, V increases. If V increases, I increases. These two together change only as amount. V, omega, and V back. Increase, decrease, always. If these two increase, other two decrease. If these two decrease, other two increase.